Here we are at our Monday corresponding angles notes example 1. Before we dive really into that though, we're going to talk a little bit about some of our definitions. So when we see parallel lines, this is something we've seen in the past. You notice that they're just two lines that will intersect, they'll never touch. And congruent angles can actually be formed when you have a transversal. So when you have, two parallel lines, as you can see right here, and you have this transversal that kind of slices through those two parallel lines, you start to create a lot of these congruent angles. And today we're going to really discuss a lot about corresponding angles. But again, you have two parallel lines, this transversal comes into place, and then you have a lot of different congruent angles. And congruent angles are pretty much just the same thing as saying they have a lot of equal angles in that process. So let's go ahead and look at what corresponding angles are then. Corresponding angles are two angles that have the same place with respect to the transversal, but in different lines. Usually when I teach this, I always say, hey guys, they're on the same side as this transversal. And so notice how X here is on the same side of this transversal. But with your two parallel lines, one is always going to be on the inside and one is on the outside. Now these two are corresponding angles. There are other types of corresponding angles, as we can see over here with Y. Notice how it's on the other side of the transversal. But those two on the Y's are on the same side. Agreed? Like this is your transversal, and they're on the same side of that transversal. They can also be in other positions. So as we see here, Z, one's on the inside, one's on the outside, but they're on that same side of the transversal. And again, likewise with W, they're on the same place, as you can kind of consider that the same side of that transversal. One's on the inside, one's on the outside. Those are corresponding angles. And there's a definition that says corresponding angles are always going to be congruent every single time. As long as you have two parallel lines and a transversal slicing through both of those parallel lines, you're going to have corresponding angles that are congruent. High school geometry is going to talk a lot more about that, and they're going to use that a lot more, but we're kind of seeing like the foundations of that process. So now let's go ahead and look at example 1. For example 1, we're asked to find the measure of angle B. Well, here we notice that we have two parallel lines. We know that they're parallel lines because it shows this little symbol here. Anytime you see that, it's indicating mathematically that those are parallel lines, okay? And our goal here, again, is to find angle B. We do see this transversal right here, slicing through both of those parallel lines. And by definition, corresponding angles are congruent. So here we see angle B and angle, or 114 degrees. Those are in the same place with respect to corresponding angles. They're on the same side of the transversal. One's on the inside, one's on the outside. And so as a result, angle B would then be equal to 114 degrees because corresponding angles are congruent. Okay. I'm just going to jot that down just to help remember. Corresponding angles are congruent. And you're going to use that quite a bit, actually, in this class and in high school. But again, though, that is example 1 from our corresponding Monday notes.